Hello students, welcome back. Previously we went through the first example out of section 2 of this notebook. This example problem which came from business. Also, this is the most important of these three because this is a business algebra, so of course business application is going to be more important than other kind of applications, and that one came from business. Now, how about the second problem? And this one, not directly related to business, it's more of a geometry problem. Let's see. Stop the playback and read through. What do you hear? So basically, a farmer is trying to maximize the area of his farm when he has the fence materials and helped by this river. Now, if there were no river, and then if he has just fence materials in just plain field, in that case, there's nothing to work out. You'll have a square because of the symmetry. But then again, because of this river, things are a bit different. You see, the fence materials have add up to 4,000 meters. So x vertical and another x vertical, and this horizontal will have to add up to 4,000. You see, x plus this horizontal has to add up to 4,000. X plus another x plus have to add up to 4,000 like this, and flip these to the other side, you get 4,000 minus 2x, and that's 2x, excuse me. That's how we got this. Let's see, horizontal, let's say it's width. W, width. But then again, it's not the perimeter or the fence material that we are working on. We want to model the area. What is the area of this rectangle? This width times vertical x. So area is W times x, which is 4,000 minus 2x times x, which is 4,000x minus 2x squared. Did I do this right? Let me rewrite it once more. That's what we get. So that's the area, and we want to maximize this area. Maximizing this quadratic model, does it make sense? Yes, it does, because we have negative a value, so the graph will be concave down, we'll have maximum. And this one is general form. And how do we get the maximum? Well, I see this right away. Factor negative 2x out, then we have an x here, and then minus 2,000. Did I do this right? So 2x squared, entire 2x out, and then 4,000 divided by 2,000, and we took negative out, so we have sign change. So what do we have? We have a intercept equation here, and from here I can easily see the basic shape of the graph. Like this. X equal to 0 here, and then right here 2,000. That's when we have area 0. So x gets really small and becomes 0, then we have really flat, and then x gets so large that it reaches 2,000 and we have very then either way area go down to 0, and then somewhere in the middle, as a matter of fact, due to the symmetry of quadratic model, at the average value 1000, we have to have the maximum. Make sense? You see, this intercept form can be obtained easily, and it helps you a lot. Let's get out of the drawing mode. And then another way to get the same thing is negative 2x minus you're going to get something like this. And how did you know that this is 1000 squared here? H value is 1000. Well, we just saw that, right? X equal to 0, x is 2000, and then the average is 1000. We get that. And then plug in x equals to 1000 here and do your computation. Then you're going to get your k value. Let's see, 1000 minus 2000, so negative 1000. And then another 1000, so 1 million times 2 million. Okay, all right. Numbers were rather humongous, so anyway, looks like that's the vertex form. But then again, as before, the vertex form is kind of tricky to get, and it's not always useful. So let's not worry about this. Let's work out the general form, which we got by multiplying w times x, and the intercept form, which we got by simple factorization. Okay, let's see. From here, h value is 0 plus 2000 over 2. So 1000. Okay, and then k value is a of h, so a of 1000. And let's see, here, let's plug in 1000. Here, 1000. And 1000, negative 1000, negative positive. 1000 times 1000, 1 million times 2, so it's 2 million. Is that true? I can always check with calculator. Yeah, it's 2 million. So that's the answer. The maximum takes place when x is 1000 meters. And then area for that is 2 million square meters. And the width is, let's see, 4000 minus 2 times 1000. So 4000 minus 2000, so 2000 meters. Area is 2 million square meters. I guess that's all the dimension we need here. What do we have in this solution here? Okay, x times 4000 minus 2x, and yeah, factored the same way to get the intercept form, and that gave me a graph like this. Do you recognize that? It's the same graph that I drew with my crude drawing mode. This is correct form, and at 1000 we reach the maximum, okay? And then, 0 plus 2000 divided by 2, that's how we get the average. That's 1000. and plugging 1000 to the area form, either to the general form or intercept form, either way it's okay. You're gonna get the K value, the maximum area. And there's a problem asks you to find out the largest area. It asks us to find out the largest area, so that's the end of the problem. If the problem asks you to find out the dimension, then it's 1000 by 2000, in which case we have 2 million square miles. We can answer like that. So we went through another model, another quadratic model, and we had the general form, intercept form, and the vertex form. Vertex form was a bit difficult to get, so we didn't really use it. But if you prefer to use the vertex form, and if you're comfortable with using the vertex formula, as we see over here, like these, yeah, h is negative b over 2a, k is negative of b squared minus 4ac over 4a, those kind of things, then you're welcome to use the vertex form. It works too, just a bit more cumbersome.